Welcome to the deep dive, where we take these really complex topics and, well, we try to unpack them. We break down the core parts and give you knowledge that actually sticks.
And today we're tackling a big one.
A huge one. The absolute infrastructure of the digital world, computer networks.
It really is the nervous system of modern society.
Totally. It's this hidden foundation that makes, everything from global finance to ordering your morning coffee possible.
Everything.
So our mission today is to get past the surface level. We want to quickly grasp the real foundational concepts, not just what a network is, but
Why it is, why it exists, how it works, and where it came from.
exactly. And the origin story is maybe the most surprising part. It tracks back to just a handful of American universities. Okay, so let's unpack this.
Right. And the material we have it's really good at laying this out. We have to start with the basic building blocks. What's the absolute minimum you need for a network?
Yeah.
But then we pivot, and we have to pivot quickly to understand the rules and the tech that lets it all happen on a massive scale.
And we're going to get into the 6 critical purposes they serve, right?
We are. We'll connect the abstract ideas to, what you actually do every day. And then, we'll build that story around ARPANET. We need to understand the history to get why we have what we have today.
I really like that the sources start with this human analogy. It makes it so much easier to get. It says, just like people have a social circle to interact.
Devices need one too.
Yeah, for interaction, for sharing resources, devices in the digital world have to have one as well.
And it's a perfect way to put it. That interconnected space, that environment, is what we call a computer network.
So what's the formal definition? What's the absolute minimum?
Well, academically, it's pretty simple. The minimum requirement is just at least 2 devices communicating with each other.
That's it, just 2.
That's it. But, and this is a huge but, that simplicity is kind of a red herring. Because it's not just that they're connected. It's how they're connected. It's what rules, what language they're using to talk to each other.
Okay, that's the crucial pivot right there. Because if a network is just 2 devices sharing something, why does everything feel so vast and complicated? Doesn't that simplicity just vanish the second you go beyond, say, your own desk?
It absolutely does. It vanishes immediately. Because for those 2 devices to talk, they need an agreed-upon language.
A protocol.
Exactly, a protocol. And they need a defined path for the data.
Yeah.
And, if those devices are far apart, they need guides, we call them routers, to chart a course for that data across maybe hundreds of other networks in between.
So it's not one big network.
No, not at all. And that's the key. Understanding computer networks is realizing the whole thing is really a network of networks, all held together by these standardized rules.
Okay, so definition. Simple. Mechanics. Incredibly complex. That means the real insight has to be in the why. Why did we build this massive layered system in the first place?
The utility is what drives the scale.
Computer networks now have, almost limitless uses. But what are the core jobs they do? This is where it gets really interesting for me.
Well, the research points to 6 essential purposes. And we can kind of group them into 2 buckets: resource sharing and then coordination and management.
Okay.
And these functions, they really explain why modern life, modern efficiency, is just impossible without networks.
So let's start with the first group, resource sharing.
Let's do it. This is what defined the early days. First, you have hardware sharing.
The classic example being the printer, right?
The printer is the perfect example. Before networks, if you wanted to print, you pretty much needed a printer sitting on your desk.
Which was a huge capital investment for a company.
A massive one. Now, a single, expensive, high-capacity printer can serve 100 people. That's not just convenience. It's a fundamental shift in how a business operates and spends money.
I think people really do forget how revolutionary that was. That a digital connection could solve a very real, very expensive physical problem.
It was huge. The second one is file, data, and information sharing.
The collaboration engine.
Precisely. Think of shared drives, version control, instant access to a company's entire knowledge base. It means multiple people can work on the same project at the same time.
You're eliminating bottlenecks. No more passing floppy disks around or having 10 different versions of the same document.
Exactly. And the third one in this group is software sharing. Instead of installing, say, 100 individual licenses on 100 different machines,
you run it on a central server and people just access it.
You got it. It makes updates so much easier. It ensures everyone's using the same version. And again, it saves a ton on licensing costs.
So those 3 points, hardware, files, and software, they basically make the network the foundational tool for any modern organization.
They are the absolute bedrock of operational coordination. But the next three purposes, they shift the focus. They're more about dynamic, real-time communication and centralized control.
This is where it moves from just sharing documents to, well, enabling how we all interact globally now.
Absolutely. This is where it gets into connectivity and command. So number 4 is providing image and sound transfer.
And this one changed everything. Socially, corporately, everything.
Overnight. This is the tech behind instant messaging, global video calls, streaming. I mean, if the last few years taught us anything, it's that being able to send high-quality sound and video across continents instantly is, well, it's non-negotiable now.
It's what allows for distributed workforces, for global supply chains to be managed in real time.
It is. Then you have number 5, central management. This is critical for reliability. It lets one network administrator oversee and secure an entire ecosystem.
Even if it's thousands of devices.
Thousands of devices from one single point. This is how you push out security patches, update operating systems, and just keep everything running smoothly and consistently.
And the last one, number 6.
Support. Networks allow for instant remote access. So instead of flying a technician across the country to fix a server,
They can just log in, run diagnostics, and fix it from anywhere. It reduces downtime massively.
drastically, it makes the whole system more resilient.
What's so wild is that the same core idea, data packets moving along these set roles, is behind chatting with a friend across the world and centrally managing 500 laptops in an office.
That's it?
These 6 purposes really do show why networks are so necessary. They enable these huge gains in efficiency and responsiveness.
They do. They define the practical need. But this all begs a pretty important question. This complex, coordinated system didn't just pop into existence.
Right. How did we get here? How did this evolve from some military experiment into a global utility?
The history is crucial, and it's often overlooked. When the technologies that would become the internet first showed up, they were nothing like what we have now.
It was tiny. The use was very limited, and from what I understand, mostly for military purposes.
Heavily military, yes. And for that, we have to introduce the foundation stone, the Advanced Research Projects Agency Network, ARPANET.
This was a project of the U.S. Department of Defense's ARPA.
That's right. And it is, without question, the direct ancestor of the modern internet. The core technologies developed for ARPANET, especially something called packet switching.
Which is breaking data into little chunks.
Exactly. Those technologies are the direct basis for every single internet technology we use today.
So what was the military's goal? It wasn't about sending faster emails, was it?
No, not at all. The main driver for ARPANET was survivability, resilience.
This was in the context of the Cold War.
Precisely. The military needed a communication system that didn't have a single point of failure. If one central hub was, say, destroyed in an attack, the information had to be able to reroute itself through any other available node.
So that redundancy, that ability to survive, was built in from the very beginning for strategic military reasons.
It was, and that's what ultimately allowed the network to scale up so massively later on.
And we can actually pinpoint the moment this idea became a reality. The planning was earlier, but 1969 is the big year. That's when ARPANET actually connected a real physical computer network.
That is the turning point. In 1969, ARPANET connected its system to 3 university networks in the U.S.
And which ones were they?
UCLA, the Stanford Research Institute, and the University of Utah.
Just 3. You have to stop and think about that. The entire global internet began as this highly specialized, very expensive military project connecting just 3 research labs.
It's a powerful detail, isn't it? The sheer smallness of that starting point. It was contained, and it was really just for academic and government researchers to exchange data.
So what happened next? What's fascinating here is the sheer scale of the expansion.
Well, that initial structure, using those shared rules, it proved the concept worked. Interconnected computing was viable, so it started connecting to more research institutions.
And then businesses got involved.
Then commercial networks started to join in. And slowly but surely, this military and academic project started to become a civilian thing. The internet, at its core, is just the structure of ARPANET, that network of networks expanded to a global scale.
That helps clarify something I think a lot of people get confused about. The difference between, say, the internet and the cloud.
That's a great point.
The internet is the actual infrastructure, right? The network of networks that grew out of ARPANET.
It's the physical and logical structure, yes. The roads. The cloud, on the other hand, is just a service that runs on those roads. You're just using the internet to access shared resources like storage or software. that are sitting on some remote server that you're probably renting.
Understanding the network means seeing that the foundational structure, the internet, is what makes all these modern services, like the cloud, even possible.
It's the ultimate story of scaling up. A network that started with just 3 academic nodes expanded to cover the entire world, becoming the definition of communication. It enables everything from, central security for a global company to sending a photo to your family.
It provides so much clarity and a real narrative that ties it all together. So let's put all these pieces together. What are the biggest takeaways for anyone listening?
Okay, so I'd say there are 3 main nuggets. First, we've got the definition. A computer network is, at its heart, just 2 or more devices talking. But its real power is in the rules and structure that let it scale.
Right.
Second, we detailed those 6 essential purposes. We have to remember that networks are tools for both resource efficiency, like sharing printers and files, and for dynamic coordination, like video chat and central management.
And the third?
And third, we tracked its very specific origin story, back to those 3 university networks connected by the military's ARPANET right back in 1969.
That structure is incredibly robust. It really is. And it leaves us with, I think, one really provocative thought to end on, build right from that history.
Go on.
If the very foundation of the modern internet, this thing that defines almost all global communication and commerce today, was an unexpected byproduct of a tiny military-focused network connecting just 3 universities, what small, unexpected, maybe even experimental structures are being built right now?
In fields like, what, quantum computing or decentralized mesh networks?
Exactly. What's being created today that 20 years from now will fundamentally redefine the way we all access information and communicate with each other?
That's a profound question about how these things evolve.
It is. Well, thank you for joining us for this deep dive into the world of computer networks. We hope you feel thoroughly informed about the complex simplicity that's running your digital life.